Hello, welcome. Let's try to solve another Leetcode problem 754. And for this problem, I'm gonna explain two kind of a method. So one is the BFS, it is not working. Another is mathematics. Let's first try to understand the problem. So the problem is that we are starting from a position. So this position, this dot is gonna be on 0. So we can move to the left side, or we can move to the left side, or we can move to the right side. But for the first step, we can move one step. So for example, we can let's start starting from here. We can move one step to the right, so it is +1. It means one step. And for the next step, we're gonna increase one, so it's gonna be two steps. So it means from 1, we can jump to 3. And for the next one, we can jump to 3 steps. So it's going to be a +3. So it's going to be a 6. Yeah. So for the next one, it's going to plus a 4. So it means we can jump to 2. Yeah, we can go to 10. So if the target value is 10, so what is the minimum steps? So there are 4 steps. So we can go this way, go here and here. Yeah. So the problem is that we are going to calculate the minimum number of moves required to reach to the destination, because we can move to the left, or move to the right according to the rule. The rule is for the next step we're gonna plus a 1. Yeah, so for each move we can move either left or right, and during each move, and we can take I steps. So this is the idea. Let's first check about the brute force idea. So that is BFS. So for the BFS idea, let me check this code. We're going to prepare a queue, and we're going to start from the beginning. So this is 0, the first 0, it means the position. So we are starting from position 0, and how many steps do we need? The minimum steps, we're going to need 0 steps from the beginning, and we also need to I didn't prepare this visited set. I think it is okay, but definitely this is not working. Yeah. So we're gonna check the queue, and we're gonna pop out the position and the steps. So if the position equals to target, we're gonna return the number of steps. Otherwise, so the steps are gonna plus 1, and the queue needed to append the position plus the steps. It means the next position, all the position can minus the steps. Yeah, but for the steps, it has already plus a 1, so we just needed to have this kind of steps. Yeah, maybe I can also use this visited set. So if it is not inside, I would to put it inside. Otherwise, I will not do that. But definitely, this cannot solve the problem. Yeah. So if this tuple not inside the weighted set, so first of all, weighted set gonna add this tuple. Yeah, let me just copy this one maybe, and the queue needed to append this one. And similarly, I will copy the same code. Yeah, it means if it's from some place, if we've already visited, we don't need to visit it anymore, because in BFS, definitely it will increase the steps. Yeah. So if the position minus the steps, and the steps not inside the weighted set, so we want to put it inside the weighted set, and queue need to append the position minus the steps. Yeah, so let's just check this idea. This is a very basic BFS idea. As you can see, it can pass some testing cases, but it cannot pass all testing cases. Yeah, if everything's okay, I think we can at least pass some testing cases. But as you can see from here, if the target value is too big, definitely we're gonna get memory excited issues. Yeah, because for BFS, normally we will get memory excited issues first before we get the time excited yeah, time exceed the limit. So first of all, it's gonna be memory exceed the limit, and then the time will exceed the limit. Normally for DFS, it will get time exceed the limit, but for BFS, first of all, it will be the memory exceed the limit. Yeah, so definitely this is not the right way to solve the problem. So we don't need to analyze the time complexity for that one, because that one, yeah, gonna really take the time. Yeah. Now we're gonna use the mathematical idea to solve the problem. So for the mathematical idea, let's just analyze the problem like this. So first of all, no matter this number is a positive number or a negative number, it doesn't matter. Maybe it is a 10 or maybe it is a negative 10. Yeah, because according to the position starting from 0, and this is a symmetric. For 10 and negative 10, it is a symmetric. So if it is a negative value, we're going to turn it to a positive value, because definitely the steps going to be the same. So we have to understand that. So now, if we go to the right side, so for the first step, we can go from 0 to 1. So we need one step. And then we go 1 to 3. So we need 2 steps. Then we go from 3 to 6, so we need 3 steps, and after that we're going to need 4 steps, so from 6 to 10. So this is going to be 4 steps. Yeah, so this is going to be the minimum steps. If everything's okay, we don't need to go back and forward, we just need to go forward, and our target value t equals to 10. If t is 10, exactly 10, and if we are going forward like this, directly go forward, plus 1, plus 2, plus 3, and plus 4. So we just need to return how many steps. So for the steps, I'm going to use a variable k. So currently, this k equals to 4. It means I only need to have 4 steps. Now let's analyze the formula. Maybe this value is going to be bigger than the target value. Yeah, because currently the target value is 10. So what about if the target value t, if the target value is 8? Yeah, so this is, let me rewrite it here. So what about if the target value is 8? What are we going to do? Yeah, definitely we cannot jump 4 steps, because after 4 steps forward like this, we go to 10. Yeah, so that means we're going to use some mathematical formula to solve the problem. So the formula is going to be like 1 plus 2 plus some value we don't know, and plus some value until k, and it's gonna equal to some value. Yeah, so 1 plus 2 plus some value plus k gonna equal to some value. But if it is equal to the target, so everything is okay. We just need to return this k. Yeah, but if it is more than target, so we will consider, first of all, we will exceed the target, and then we will go back to check if it is possible. Yeah, so if this is more than the target, so this means this value gonna be equal to a target plus a d. So this d is just the difference. Maybe this d is 1, 2, 3, or 4. It doesn't matter. But definitely this d gonna be a positive number. So if d is 0, this means this value equal to the target. It is okay. We just need to return this k. But if this d is a positive number, it can be even number or it can be odd number. It doesn't matter. Yeah. But for us, we need to analyze. Yeah. So if it is possible, I mean from 1 plus 2 plus some value to k to equal to k plus a d, if it is possible, it means it must be somewhere. It must be somewhere if we want to reduce the total sum of the values to t. If we want to reduce these values to t, because from the right side we can minus a d, and then the value gonna be t. And for the left side, we just need to reduce some value, but we don't know where it is. Maybe it is starting from somewhere, like 1 plus 2, plus some value, and then minus a value. So we're going to minus a value I, and plus some value, and plus a value to k. Yeah. So this means we want to minus a value from some place. We don't know where it is, but we just guess. Maybe it's from somewhere. And we want to let this value equal to target. So this means from the right side, we're going to reduce a value d. It's going to be equal to t. And from the left side, we're going to turn the positive value to a negative value. Before it is a positive I, now it becomes a negative I. So this means according to this formula, 2I gonna be equal to D. Yeah, because if we turn a positive value to a negative value, it means definitely we reduced 2I values. And from the right side, we reduced the value gonna be D. It means 2I equal to D. Yeah, so this is our formula. Yeah, so this means if D, yeah, so this means if D is an even number, so this means if D is an even number, definitely it is possible, and we don't need to increase any steps. Yeah, as you can see, 2I equals to D, and D, 2I must be an even number, so we just need to check. If D is an even number, definitely it is possible. So this means D is the difference from 1 plus 2 plus something plus k minus the target, gonna be equal to this value D. So this means if D is an even number, definitely D modular 2 equal to 0. Yeah, so if D modular 2 equal to 0, it means D is an even number, so definitely we're gonna return k as well. Yeah, so this is one case. Now what about if this D is an odd number? You know, if D is an odd number, definitely 2 times I gonna be an even number. It is not possible. So if it is not possible, what are we gonna do? Maybe we just want to go forward one more step. Yeah, maybe it is possible, we don't know, but let's just guess. Yeah, so if we go forward one more step, it means from here we're gonna plus another value. It's gonna be k plus 1 because we want to go forward one more step. So what is the final result? So the final result gonna be 2I plus the one more step plus k plus 1. Yeah, so we want to check 2I plus k plus 1. Can this value equal to our difference in D? Yeah. Now D is an odd number, so we're gonna turn this one to the left side, D minus 1 here, and we clean up here. Yeah. So now the problem becomes D minus 1. D is an odd number, D minus 1, an odd number minus an odd number, so D gonna be an even number. So currently we turn this difference to an even number, and now from the left side is 2I plus k. 2I is an even number. It means if we want to let the formula equal, so this k must be an even number, because 2I is even number, and from the right side D minus 1 it is even number, so this k must be an even number. So if D, the second case is that if D modular 2 equals to 1, we have to check if this k is an even number or odd number. So if this k is an even number, it means k modular 2 equal to 0. So if this k is an even number, it means it is possible definitely, and the result gonna be k plus 1, because from here we just need to use a k plus 1. Yeah, but what if this k is an odd number? It means k modular 2 gonna become 1. Yeah, let me just clean up maybe a little bit. Yeah, so what if k modular 2 equals to 1? If it equals to 1, it means it means this k gonna be, because currently we don't know if this k modular 2 equal to 0 or 1, but if it is equal to 0, we're gonna return k plus 1. Yeah, definitely this k can also become an odd number. So what about if k modular 2 equal to 1? Is that possible? Yeah, so for our formulas it is not possible, because our formula it only meets the conditions like 2i plus k, 2i plus k equal to d minus 1, and d minus 1 is even number, and this is even number. Yeah, but what if this k is an odd number? It means 2i plus k gonna be an odd number, but from the right side it is even number. It is not possible. If it is not possible, what are we gonna do? We just need to have one more step. We just need to let go forward one more step. It's gonna be k plus 2. So what is gonna be the final result? So the final result gonna be, let me clean up. Maybe I'm gonna write it here. Yeah. So the final result gonna be 2i plus k plus 1 and plus k plus 2 gonna be equal to d. Yeah, let's turn the 3 to the right side. It's gonna be 2i plus 2k, this is 1k, 2k plus 2i gonna be equal to d minus 3. D minus 3. As the d is a even number, d is an odd number, so an odd number minus an odd number, so it is an even number. Yeah, so this is gonna be an even number. And let's check the left side. 2k plus 2i, definitely this is also an even number. So that means it is possible. So if k modulo 2 equal to 1, we're gonna return a result. It's gonna be k plus 2. Yeah, so this is why we can use the mathematics skills to solve this problem, but we have to analyze all different cases, and that is all the different cases. Yeah. Now let's go back to the code. Let me go back to the code. So first of all, we're gonna check the target. If this target is a negative number, we can turn this number to a positive number. So target is gonna be equal to minus target. And then we're gonna prepare a k-end result. And this result is just the total sum from 1 to k, like 1 plus 2 plus some value to k. Yeah, so this is the result. And this k is just how many steps. It's my final return. Maybe I'm gonna return k or k plus 1 or k plus 2. Yeah, so for the first step, the total sum result is 0. It is less than the target, because the target is gonna always be positive. Yeah, so for the k, it's gonna plus 1. It will go to the right side. So k gonna plus equal to 1, and the total sum gonna plus equal to k. It is okay. Now, if this result equal to the target, or if the result is more than the target, and the difference modulo 2 equal to 0, it means the d is an even number. So we're gonna return k. Yeah. And another case is that if the result is more than target, and the result minus the target is an odd number. So if it is an odd number, we have two different cases. It always depends on k. If k is an even number, we're going to return k plus 1. Otherwise, if k is odd number, so we're going to return k plus 2. Yeah. So everything is just a mathematical formula. We just need to analyze. For most of the time, we need to analyze the formula, and the coding going to be easy to write, but the analyzation for the formula is going to be really difficult. And this is going to be the final code. And everything is just from here. We need to check a lot of mathematical formulas to get the final result. Yeah, sometimes we can guess. So if the target is going to be a really big value, what are we going to do? We're going to always go forward first until we exceed that target value. What if we exceed the value? Maybe we're going to check what's going to be the possible result of the k, or what might be the possible result of this d difference. Maybe it is an even number or an odd number, or maybe it is also considered with k. Yeah, but for everything inside, it's always about the mathematical formula. We have to get the mathematical formula to get the final result. Yeah, now let me just run it and check if it works. Now let me submit it to check if it can pass all testing cases. Yeah, as you can see, it passed all testing cases, and it's pretty fast. And because the time complexity is the square root of n. Yeah. So because here actually we are calculating 1 plus something plus k to a target, and this target is going to be 10 to the power of 9. Yeah. So it means the final time complexity is the square root of 10 to the power of 9, the square root of target. Maybe the final value is going to be 10 to the power of 4 or 5. That is why it is so fast. I think this is a really good problem. Yeah, because in order to solve this problem, definitely you cannot use your previous experience of data structure and algorithms. You cannot use that. Everything is just about mathematics, about generalization according to the description. If you can generalize some kind of a mathematical formula, and then you can solve it. Thank you for watching. See you next time.